We're going to migrate business data from a SQL Server database into a Postgres database using Python and SQL. And we're also going to visualize our results in matplotlib. The data source is SQL Server. So this has a UAT database that contains the business data we want to migrate into Postgres. And Postgres is going to be the target database for this project. So we want to get the data from SQL Server, transform it to match Postgres' format, and load it into our destination, which is Postgres. And we're also going to validate the data before and after the migration, just so that we know that the data looks correct at each stage. And we're going to visualize our results to show our stakeholders whether it's safe or not to run the same migration in the production environment. With projects like this, we need to understand what we're getting into first. So 2 questions I'd like to ask is, number 1, what's the problem? And number 2, what does success look like? Now, this may sound obvious, but you'd be surprised at how many people have assumptions of what the data project's about and the approaches they should take in solving this. So if everyone has different interpretations of this could single-handedly become a more expensive project than it should be. And we may even waste time on initiatives or priorities that don't mean anything to our end users. So aligning ourselves with what the end user actually wants is one of the most important first steps of any data project. So, what is the problem? An e-commerce company has been running their business on SQL Server for 5 years, but licensing costs are expensive. So there's clearly cost pressure. The licensing fees for SQL Server are getting more expensive as they're scaling to more database servers. Reporting queries are getting slower. So the data team are complaining about how slow their reporting queries are getting by using SQL Server, no matter how many optimization techniques and approaches they try out. And they want to migrate to the cloud. Now, the company wants to move to the AWS ecosystem, and Postgres is cheaper and better supported there. So this is one of the reasons why leadership have decided to migrate into PostgreSQL. Well, here's the thing, right? They're not going to approve any production migration until the data engineering team proves it perfectly works in UAT first. So the question is, what is UAT? So UAT stands for User Acceptance Testing. And this is basically an environment to test a feature before it reaches real users. Think about it as a safe environment where you test changes before they go live. There are 2 environments, right? There's production environment and there's UAT environment. So production is the live system where real users or real customers make real purchases. And UAT is going to be a copy of production. And that's where you can test any changes and it doesn't affect any real customers. So if you mess up in UAT, then you can just fix it and try again. So there's no problems there. It's like a sandbox environment, or what some will call a playground environment. Now, if you mess up in production, the website breaks, customers can't buy anything, and you're on a call with the CEO at 2 a.m. in the morning. So this is why companies test database migrations inside UAT first. Instead of hoping the migration works and crossing our fingers, we need to prove it works. For us, this is what success looks like. All 4 tables migrate into Postgres. Okay, it has to be successful. So for the tables we got customers, products, categories, and suppliers. All of those tables need to be moved into Postgres. No data loss is recorded. The data must match exactly between SQL Server and PostgreSQL. So that means the row counts are equal between both databases, data type matches, and the columns, etc. And all data quality checks pass. So why does a project like this even matter? So enterprises migrate data between systems all the time, and they have reasons for it, okay? So a startup that begins with MySQL may want to migrate into Postgres because it performs better for their use cases. Or an enterprise that uses Oracle may want to cut on costs by moving to open source databases instead. So this is one of the reasons why companies pay engineers well, because they have the experience with all of these and they can be trusted with high-stake projects like data migration comfortably. So a project like this gets you a step closer to becoming a part of that group and even stand out in interviews. Because if you're comfortable with industry problems like this, then you'll have less imposter syndrome when you come across these projects in the industry. Companies need people who can migrate databases without data loss, validate migrations with code and visuals, and build production-grade data pipelines. So all of these skills are essential, especially in the world we're moving into now. We're going to need more people who are skilled with this comfortably. But let's quickly get into the fun part. Okay, so let's now move into design. So we need to ask ourselves 3 questions. Number 1, what tables are we migrating? Number 2, what does good data quality look like? Number 3, what does the pipeline look like? So number 1, what tables are we migrating? So in short, we have 4 tables that are in SQL Server that need to be moved into PostgreSQL, right? We have customers, suppliers, products, and categories. So in fact, I think it's actually best for me to show you what those tables look like. So let me actually open up SQL Server for you. So I'm going to go into my search and just type in SQL Server Management Studio. And I'm going to connect to my database. Now, I'm going to expand databases. I'm going to show you the data we're working with, okay? This is what we're trying to migrate into PostgreSQL. We have 4 tables in our transaction DB UAT, right? So if I just show you what each of them look like, let me just select top 1000. As you can see, this is the categories table. And then I'll show you the customers table. And we're trying to migrate the products table. And we're trying to migrate the suppliers table. So I am going to show you how many rows exist in all of these tables. So I am going to type select. Let's start with the categories. And I'm going to say as table name. And then I'm going to do count star as total rows from categories, right? Now, if I do that, that's going to show that categories has 8 records. So if I go to categories again, as you can see, these are the records inside the categories table. Now, I want to see how many rows exist in all of those tables. So I'm going to use union all. And then I'm going to select what table's next. We have customers table. Okay, so let's try customers table. And I don't need to write as table name this time because I'm using union all. And that's helped me define the name of this column. I'm using union all because I want to stack all of my results on top of each other. Okay, the results for this query is going to be here. The results of the query I'm going to write will now be stacked right below this. I'll show you what I mean. So this is the name of the table. And then I'm going to use my count again. And I don't need to give the name of this field either because I've done it the first time. And I'm going to type from customers. So if I just run this, let me just show you the query. Let me make that smaller. So this is my first query, my second query. So the results of this is going to be stacked on top of this. And I'll show you. As you can see, the results of this query is now stacked on top of this. And that's thanks to the union all operation. So I'm going to apply the same process to these ones. And if you want, all you have to do, just copy this and just replace that with the name of each table. So products for that one. And then union all. And if you want, just for visual hierarchy, you can actually, I know this is long, but I'm going to make the select and from of each of the queries in smaller cases, right? For me, it's just visually easier to differentiate between each of the queries. Okay. So select. It's not going to impact the query, but it's just for readability. Okay, and the final one is going to be suppliers. Okay, so if I just zoom out real quick, that's my first query, my second query, my third one, and my fourth one. And let me just do this. Okay, so if I run this, as you can see, all 4 tables, I've now got the row count for all 4 tables. Now, what if I want the total of all of these? What do I do then? I can do something interesting. I can create what we call a CTE. So with, let's say, SQL Server, let me do it in lower cases. SQL Server table count as, open up a bracket, and then I close a bracket or add a close bracket. I can now say select, and then I type in sum. I'm going to say total rows. I believe that's what I called. Yeah, okay. So we're going to say select sum total rows as grand total rows from my SQL Server table count. And if I run this, I now get the total row count of every single table I've included here, right? Just like that. And if I want to be extra smart, I'm going to add 1,000 separators. So add a hash followed by a 0, and I'm using the format function. So the first argument is my sum total rows, and the second one is this fancy bunch of characters put together. It's a hash followed by a comma followed by 0. So if I run this, I get 1,000 separators. And I know for a fact this is over 1 million records. So we're trying to process over 1 million records from SQL Server into Postgres. So we know we've done a good job when we have 1,055,008 records inside Postgres across all these 4 tables. The migration must preserve this data. We must not lose a single record or cell or character in any string or any number. So how do we know we've done this correctly? So that's what's going to lead us to our second question. What does good data quality look like? So we need to check the data quality before migration and after migration. The data quality checks we do before migration is what we will call pre-migration data quality checks. The first check could be row counts. So the row counts must be over 1 million records. So we've just confirmed that the row count has to be 1,055,008 records in SQL Server and in Postgres. Number 2, no nulls in required fields. So check number 2 will be a null check. Okay, so things like the customer name should not be null, the product name should not be null, email should not be null, right? So if you go into the customer table, so yeah, so customer ID, so fields like this shouldn't be null, right? Customer name shouldn't be null, email shouldn't be null, right? And that's what we need to confirm. Okay, I can see nulls in the customer name already. It's important for me to note, right? There are some issues that we're going to notice, but we're not going to resolve them. That's because the focus of this migration is not to fix issues per se. It's just to move the data from one system to another system. So we're going to flag the issues we find along the way and report them to the right key contacts within the data teams so that they can apply the right fixes to them. We can make them aware of the data quality issues we find, but we ourselves are not going to fix these issues. That's out of scope for this data migration project. So if I keep scrolling, I'm probably going to find more issues. Aha. So there's a null here, and there's a null here. So once again, we are not fixing data quality issues, we're just highlighting them. Okay? And this is just to make the data team aware that they need to come and sort out their data. Whether they want to fix it at the source level, at the SQL Server level, or they want to rectify that once the data hits Postgres. That's going to be up to them. Number 3, there must be no orphaned foreign keys. So let me explain what an orphaned foreign key is. First of all, an orphaned key is a key that points to a primary key that doesn't exist in a parent table. So an orphaned foreign key is when a products record has a supplier ID of, let's say, 999, but there's no supplier with a supplier ID of 999 in the suppliers table. So that breaks what we call referential integrity. So sometimes this happens because the key actually existed, but a process deleted this primary key in the parent table without handling the child records that relate to it. Okay, so these are the records we're going to classify as orphaned records, or orphaned foreign keys. And number 4, no negative values found. So we may find some products that have a negative unit price or a negative stock quantity, which is obviously not possible in the real world. Okay, so for example, you can have 2 pairs of shoes in the inventory room, but you cannot have -4 pairs of shoes in the same room, because that's literally not possible, right? So I have 1 mic here. I cannot have -6 mics in my room because that's literally impossible. So yeah, this will be a data quality issue in the source system. Okay, so we're going to report that, but we'll migrate it as it is. And number 5, no future dates used, right? So there may be dates in the created dates column that may be far into the future, right? And similar to the other one, that's impossible because we're dealing with historical data. And by definition, this is data of the past, not of the future. So let's talk about the checks after migration, what we would call post-migration data quality checks. And these will be checks we do inside Postgres. First of all, the row count is equal in both databases, right? So each table in Postgres must have the same number of rows as their corresponding table in SQL Server. If the counts do not match, then the migration has failed. Something went wrong in our migration, and we need to figure out what that is. Okay, check number 2. Data types match in both systems. Now, because they're both different databases, they're going to have different names for different data types. Okay, so for example, a column with a data type of date time in SQL Server is the same as timestamp in Postgres, right? So they're the same data type, but they just have different names, right? And we need to make sure that we preserve this by converting any columns from SQL Server with date time data types into timestamp data types when it reaches Postgres. And another one would be money, the money data type in SQL Server. Money in SQL Server is equivalent to numeric or decimal in Postgres, so that we can define the exact precision or scale we need. All conversions must preserve the data, otherwise we may lose data. And no primary key is duplicated. And number 4, tables should be able to talk to each other correctly. So this is similar to the foreign key relationships that we need to preserve. Columns in a table must be able to reference columns in another table without any issues. So for example, the products must be able to reference their categories, and products must also be able to reference suppliers. All relationships between tables must be preserved. What does the migration pipeline look like? So we've already covered the system architecture in the beginning, but let's also cover how we're going to progress through this project, right? So first, we audit the data. Then we're going to extract data from SQL Server. After that, we transform the data. Then we load that data into Postgres, and then finally we validate the data. Let me just preface by saying you're going to need Anaconda, pgadmin for Postgres, SQL Server, and VS Code. You're going to need to install all of these tools so that you can jump on this project along myself. If you haven't got any of those on your system, check the video description for videos on how to install each of these. I've created videos for you to walk you through how to install each of these. So make sure you download them and then resume back to this part of the project. Now, I am going to open up Anaconda. So I'm just going to type in Anaconda. I'm going to open up the command prompt for this. So let me just expand this. Now I'm going to navigate into a directory that I want. So pick a directory that you're comfortable with. So I'm going to go into, let me just see what I have. So I can go into, okay, let's go into documents. And then I'm going to go into GitHub. Then let me just check what I've got. Okay, let's go into demo. Now I'm going to just clear all that. And then I'm going to type in conda create -n, and then I'm going to give my conda environment a name. I'm going to call this SQL Server to Postgres. And now I'm going to specify what Python version I want, which is 3.11 or 3.11. And then I'm just going to do -y to say yes. Now I'm going to hit enter. This may take a while, so just give it time and let Conda create your virtual environment. Okay, so it's now created my virtual environment. So what I'm going to do is I'm going to activate my Conda virtual environment. So I'm going to type in Conda activate SQL Server to Postgres. And if you notice, if you see this, this has changed from base to SQL Server to Postgres. This is my virtual environment. So this allows me to install all the libraries I need specifically for this project. So I'm going to start with pip install pandas. This will allow us to create data frames with the data we're processing, with obviously one of the most popular libraries in the data science space. Then I type pip install pyodbc. So this library is going to allow us to talk to SQL Server with Python. Pip install psychopg2 binary. This library is going to allow us to talk to PostgreSQL using Python. Pip install python.env. This library is going to allow us to secure our sensitive credentials and load it into our session. Now, I'm going to open up VS Code by just typing code and hitting enter. I'm going to go to Google or search browser and type in GitHub. And I'm going to click on the link I see from the official site. And then I'm going to go to the plus sign here and then click on new repository. I'm going to give my repository a name. So I'm going to say SQL Server to Postgres migration. And choose visibility. I'll make it public. Let me give it a description as well. Migrating enterprise data from SQL Server to PostgreSQL, let's say, and then create repository. I'm going to open up Git bash. Now, if you haven't got Git bash downloaded, I recommend checking the video description on how to download Git bash. So this is going to help us version control our assets and files. Everything we use for this project, we're going to version control. Now, I'm going to navigate into the folder that we've been working with. So C, users, Steph, documents, GitHub. In fact, let me just confirm if this works. Okay, yep. So actually CD, GitHub, so navigate into it. So this is the location I want to actually clone my GitHub repository into. So let me go back into GitHub. I'm going to copy this link here and then go back into git bash. And then I'm going to type in git clone and then paste the link I've just copied. And now, as you can see, it's managed to clone the repository. So I'm going to type in cd SQL Server to Postgres migration. And now I've navigated into this folder here. So if I say git branch, you're going to see that we're inside the main branch. If I say git status, yep, nothing's happened yet. Awesome. Okay, so now let's go into VS Code. And I'm going to click File, Open Folder, click on GitHub, and then I'm going to click on this folder we've just cloned from GitHub. And now everything we do can now go inside this folder. So the first thing I'm going to do is create a README file. Okay, so let me just say preface this project is about migrating enterprise data into or from SQL Server into Postgres. We'll be using SQL, yes, Python, and we're going to say Jupyter Notebook because that's exactly what we're going to create in a moment. Now, let's commit this to our remote branch. Okay, so first of all, let me just do git status just to show you that we've created the README file. Okay, it's currently untracked, so let's do git add readme.md. And if I do git status again, now it's showing us the changes we can now commit. So let me do git commit -m, and I'm going to say created README file. Okay, and if you want, you can do -m again and say we have created a README file for this project, right? And then hit enter, and then we're going to say git push origin main, and that's going to push it from our local repository into our remote repository. So if I was to go into GitHub, and if I was to refresh this, now our README file is showing right here. And see how it's being displayed right now. It's all in one line. I don't like that. So I'm going to go back to the README, and I'm going to change this to a dash. Okay, and then I'm going to open up git bash again. If I say git status, and then you can also do git add full stop, and then I'm going to say git commit -m changed bullet bullet points, or should we say converted or split tools into bullet pointed list, let's just say. And then we're going to push this into the main branch in our remote branch. We've pushed it. So as you can see, we're capturing different versions of the same README file. That's the whole purpose of using Git, right? So if I was to go back to this, and then if I just hit refresh, as you can see, it's now appearing as bullet points. Awesome. Okay, so enough playing around. Let's get into the real project. Before we actually do anything, what we need to do is we need to actually clearly define what we're doing in this project, right? If you've watched some of my previous data projects on YouTube, you're going to know that I like to break down the problem into simple steps first. And this is called pseudocode, right? And this is us writing out what needs to be done in plain English before we touch any code. Because if you can't explain your solution in simple terms, you'll simply struggle to build it. So this helps highlight any gaps early, and it breaks any overwhelming task into smaller chunks that I can handle. So this is going to be the blueprint that we need before building any coding project. Okay, so I'm going to split this into high level and low level steps. So I'm going to type in sudo code. So this is H1 in Markdown. This is called H1, and this is going to be called H2. So the high level, once again, we've already touched on the steps before. So I'm just going to record it here. Okay, the first step is going to be audit the data in SQL Server. And in fact, maybe we should make an audit list. So number one, audit the data. Number two, extract data from SQL Server or SQL Server Management Studio. Transform the data. Load the data into PostgreSQL and validate the data. This could be after migration. This is going to be before migration. And number 6, generate a validation report. So let's now talk about the low level. Say 1.1 for that. Actually, let's leave that. Okay, low level. So these are going to be the concrete steps we take each step of the way. So the very first step would be to create a .env file so that we can store all our passwords and usernames, hosts and all that stuff. And then we're going to load the environment variables into our session. And then we're going to need to connect to SQL Server. Programmatically, I'm going to use pyodbc for that. We're also going to need to connect to Postgres. I'm going to use psychopg2. And then we're going to be able to audit the data. And then we're going to need the row count for each table. So, okay, so we're going to enter a loop for each table. We're going to need to get the row counts and then extract all the rows. What else do we need to do? So get row counts, extract all the rows. This is the part, so we're just brainstorming through this right now. So this is the part where you really have to think, right? So no code until you clarify all these steps. Now, I'm not saying that every single micro step needs to be highlighted, but you want to clarify as much as you can, as early as you can, so that you can use this as a guide. And it just makes the project easier, because what you're going to do now is you're simply going to use your brain to convert each of these into the corresponding code logic necessary to bring this to existence, right? So yeah, that's the beauty of coding. This is what we came up with. High level steps, low level steps. Okay, so I'm just going to commit this to my Git. Oh, before I push, I think it's worth finding out what we've done. Okay, so let's add this. And then we're going to commit this. I'll say outlined migration approach. And I can also say listed the high level and low level steps via pseudocode. So I'm just making it blatantly obvious. And then we can push that into our main branch in the remote repository. So if I was to go back into GitHub, refresh that, that now appears right here. These steps are actually sub bullet points of this one. So I just need to make that clear. So let me go back to the README file. And what I need to do is, first of all, let me add a colon. So that's easy for other developers to see that these are going to be sub bullet points of that one. Yeah, so it's going to be up to here. Okay, let me do that again. So I'm going to highlight all of this, and then I'm just going to indent them. So I've hit the tab key. Let's see if this works actually. So I'm just going to open up Git Bash again. So I'm just testing to see if this actually works. We can say indenting sub bullet points correctly. Git push origin. Okay, so let's see if this works. Aha, good. So now for each table, we're going to get the row count, extract all rows, transform the columns, convert the data types, create tables in Postgres, and load tables in Postgres, and then run post data migration checks. Okay, awesome. Yep, that's what we want. So we have an idea of how we're going to go about this project, and we're going to start straight away. So let's open up VS Code, and let's create a .env file. So the .env file is where we're going to save all our sensitive credentials so that unauthorized users or malicious users do not access this. And I'm also going to create a .gitignore file. Now what this is going to do is it's going to hide any file I've included inside here from the remote branch. When we commit all of these changes into the remote branch, the gitignore file is going to help us hide things like the .env file. So if I just type in .env, you're going to see that this turns from green into gray. And that means Git has stopped tracking the .env file. So that if I add in my password, which is my super secret password, this does not get added into GitHub or my remote branch in GitHub. And that's for production purposes. This is what you must do. So do not commit your .env file into your remote branch. Otherwise, unauthorized users or malicious users may actually see your passwords or your ports or your hosts, and they may play around with it. Things like your API keys, you don't want that going inside your remote branch. So be very careful. Make sure you have gitignore as part of your root files. Now, let's get rid of this. We need to add our credentials. So I'm going to start with the SQL Server ones. And for SQL Server, I'm using a Windows authentication method. So there are different types, but I'm going to use the Windows authentication method, okay? So I'm going to start with SQL Server. I'm going to type in host. I'm going to also need SQL Server. Let me actually just copy this because I can't be asked to write it every single time. I'm going to also include SQL Server database, and I'm also going to include SQL Server user. All of this I'm going to collect from SQL Server. So let me just click connect. I'm going to click database engine. So my server name, as you can see, is going to be right here. So I'm just going to copy that. I'm just going to paste it there. And then SQL Server database. The name of this database is transaction database UAT. So I'm just going to copy the database name from the top left. You can also go to databases and then select the database and then just copy that. Or you can also right click, then click on rename and just copy the database name and then just paste it there. And SQL Server user, I'm just going to type in Windows for this one because that's the approach we're using. The next one I'm going to do is the Postgres one. I'm going to type in Postgres host. And then once again, I'm just going to copy this, just change what needs to be changed. Now, straight away, I know I'm using localhost. How do I know that? I'm going to open up pgadmin. So I'm just going to let it load. Okay, so let me just expand it a bit. Now, so I click on servers, and then I'm just going to right click PostgreSQL, and then click on properties, and then I'm going to click on connection. And as you can see, the host name is called localhost, and we've actually got the port as well. So the default is 5432 for Postgres. So I'm just going to go back to VS Code, and then I'm just going to paste that in 5432. Now the Postgres database is going to be called transaction underscore UAT. The Postgres user is going to be from here. So username, we just copy that. And then just type in username. And the Postgres password is going to be a very secure password known as password. Okay, so that's our .env file completed. The next thing we need to do is to create our Jupyter notebook. So I'm going to click on new file. And then I'm going to name this run migration UAT .ipynb. So that's the extension of a Jupyter notebook. And then hit enter. So let me just hit markdown. And then I'm just going to say data migration SQL Server to Postgres. And then I'm going to add in a code cell. That's going to be below this. Then we're going to import all the libraries that we need for this project. So let me import OS. I've imported pandas. Okay, so let me select kernel. And then I'm going to click on Python environments. And then I'm going to click on SQL Server to Postgres, the one we've created in Anaconda. And then I'm going to import the remaining libraries. So pyodbc, psychopg2, and then from .env import load.env. I'm also going to import from psychopg2 extras import execute values. This is going to be useful. I'm going to show you why later. Okay, so if you get this prompt, just click install. So I'm going to run this cell, and then I'm going to create a new cell. We're going to load our credentials from the .env file by using load env variable. It's meant to be load.env. This is going to allow us to load our credentials from the .env file into this session. Okay, and this is safer than hard coding sensitive credentials or details like passwords directly into our code. Okay, so otherwise unauthorized people, malicious people could gain access into data they should not be looking at. Now, the first thing I'm going to do is load the SQL Server credentials. And I'm going to use the OS library to help us. OS And I'm going to use the get env method for this. So I'm going to type in SQL Server host, and then let me just type in the one for database os.getEnv, and then I'm going to type in SQL Server db, right? Okay, so let's prove that this worked. So I'm going to type in print. Let's use the f string as well. SQL Server host. Then let me just copy the same for DB. Okay, did I type that correctly? Ah, it's SQL underscore server underscore host. So we have to be super accurate. Let me just add the underscore there. Let's try that again. Ah, and there we go. So now we've loaded the SQL Server host and SQL Server database we're using into this session. Now let's do the same for Postgres. I'm going to say pg host. os.getEnv Postgres host. So let me just confirm this works. Print f string Postgres host pg host. Okay, so that works. Awesome. I'm going to copy this. See, let me just copy it. The host, and then change that to ports. And then database. Then user. And then let's do password. Password. Okay, now let me just paste all the others first. Okay, so we're going to change this to ports, database, username, username, password, change that to ports, change that to database, change that to user, change that to password. So let's print all of that. Awesome. So that works. I'm going to add in a markdown cell after this. I'm going to say load credentials. Let's just say that. Should we call it step 1? Step 1, load credentials. Okay, we'll do it in steps. Sure. In the spirit of adding steps, the next step will be connect to SQL Server. We're going to connect to SQL Server programmatically, right? Now, I think you have to install the ODBC driver for this to work. Okay, so if you haven't, what you need to do is go to your browser and then type ODBC driver 17 for SQL Server. And then click on the first link from the official Microsoft Learn website, as you can see here, and scroll down to version 17, and then click on download Microsoft ODBC driver 17 for SQL Server x64. At least this is what I did for my laptop, which is a Windows laptop. Now, depending on when you're watching this video, make sure you download a version that's compatible with your laptop. Once you do that, follow the installer's instructions and then just take it from there. So for now, I'm going to go back into Jupyter or VS Code. So what I'm going to do is I'm going to set up a connection string. Okay, but first, let me just print connecting to SQL Server. And then I'm just adding things to the console so that I know what's happening at each stage of this project. Server, SQL, say SQL host. And then the database is going to be SQL DB. Okay. That's just for tracking purposes. Okay, so then I'm going to create a try except block to set up this connection. Okay, so let me just add in some placeholders. Right, so the try block will try the connection to SQL Server. Okay, so if anything goes wrong, then the exception block will tell me what went wrong. And if I'm smart, I'm going to make sure it tells me the reason why, or at least what I should do if the try block fails. Otherwise, I'm going to spend my precious time figuring out for several minutes, if not hours or days. So in the try block, I'm going to add the SQL string. So I'll just type in SQL connection string. So I'm going to do an F string. Driver equals ODBC driver 17 for SQL Server. And then I round off with a semicolon and then another F string for the server, which is going to be the SQL host. And then the database is going to equal SQL database. And of course, to set up the connection to SQL Server, I need trusted connection, and I'm going to equal yes, okay? Because if you go into SQL Server, let's say you want to connect to SQL Server, right? There's this, if you see encrypt, under mandatory, you're going to see trust server certificate. I have mine ticked. So the equivalent of this is just making sure you have trusted connection to equal yes. And then we're going to use pyodbc to use that connection string, so this one here, to see if we can connect to SQL Server. So I'm going to type in SQL connection or SQL con for the variable, and then pyodbc, and then I'm going to type in connect. So we're going to use the connect method, and then we're going to use SQL connection string. We're using this connection string to connect to SQL Server. And we're also going to set up a cursor for SQL. So we're going to use the connection string to create a cursor, right? So the cursor is going to allow us to send commands to SQL Server using Python and to receive the corresponding results that come from it. Now, if this doesn't work, all of this, if this doesn't work, this is when the exception block becomes useful, right? So I'm going to first print SQL Server connection failed. And then I'm just going to add E. It's going to return the exception, so what went wrong. And if I want, I can add a bunch of troubleshooting steps. So how to troubleshoot, in case a developer wants to try this out, okay? So number one, check server name in .env file is correct. Number two, verify SQL Server is running. Number 3, check Windows authentication is enabled. Okay, and we can add all sorts of steps we want in case this goes wrong. So I'm going to be brave and give this a try. I'm going to hit enter, and it seems to have worked. You know what I need to do? I need to print a success message. Success. You can do an arrow if you want. Connection to SQL Server successfully completed, or something like that. Yeah. Or now live. Something like that. Awesome. Okay. The next thing we need to do is connect to Postgres. And this is going to be step number 3. So we've used pyodbc to connect to SQL Server. Now we're going to use psychopg2 to connect with Postgres, right? So I could just simply copy this and just replace it with Postgres details, pg host, pg database. Okay, now enter a new cell. We're going to create try except blocks again as a, and then pass, and then this time we're going to set up the credentials for Postgres. So pg connection, that's going to require psychopg2, and that's going to require connect. Now the host is going to equal pg host. The port is going to equal pg port. Database will equal pgdb. User will equal pg user. Password will equal pg password. Now we're going to create a cursor for PostgreSQL as well. So pg cursor, that's what we're going to name this one. And we're going to use pg connection and then cursor. So we need to test if this connection even works, right? So let's just find out what version of Postgres we're on, right? So I'm going to do pg underscore cursor. I'm going to use the execute method, and I'm going to select version, right? And then that's what this does. It allows me to send commands to Postgres and receive the corresponding results. Now I'm going to read the results into a variable, okay? So I'm going to type in pg version, right? And I'm going to use pg cursor for this, and I'm going to use fetch1, and I'm going to select the very first result that comes out of that. If this works, I should be able to print connected to PostgreSQL. Should also be able to print the version. Okay, so let's type in pg version. I'm going to do something clever. Let me just type in ... and then break into a new line. So if this doesn't work, I'm going to run in a moment, but if this does not work, then It's likely something wrong with our operation somewhere. So what we can do is we can return an operational error message, and that's going to come from the psychopg2 library. And we'll also add the steps the user should take if the connection doesn't work. So I'm going to replace exception with psychopg2, and I'm going to say operational error. And I can just type in Postgres connection failed. E. Oh, let me make this an F string. And then just add all these. So that we're adding our custom message. Just type in how to troubleshoot. Okay. Step 1, check Postgres is running, let's say. Number 2, verify username and password. Number 3, check the database exists, things like that. And yeah, and so on and so forth. You get the point. We can still have a general exception as well. So print, we'll call this unexpected error. And then raise whatever. Okay, so let's try and run this. Invalid DSN, invalid connection option, PG password. Okay, let's look at the password. This is not okay. Let's remove PG password. This is not a valid. So that's not valid. So let's correct that. Let's try running this again. So Postgres connection failed. Connection to server at localhost. Okay, let's read this. Port 5432 failed. Database transaction UAT does not exist. Okay. So what we need to do is to go into Postgres and see whether it exists or not. If I was to just refresh all of this, and then just expand this, as you can see, we only have one database in here, and it's the Postgres database. So we don't have the transaction UAT one that we specified in our .env file. And that's what our error message is telling us. The solution to this is by creating a database. So I can go into databases in pgadmin, right click databases, and then click create, and then go to database. And then to be safe, I'm just going to copy the one from here and then paste into database, and then I can click save. And now the transaction UAT database exists. So I'm going to go back into my code, and I'm going to run this again to confirm if this works. And now it does, as you can see right here. It's giving us our version, and that confirms that our code works, which is great. Now let's now move on to the next step. We're going to define the tables we're going to migrate. So we need to be clear on what tables we're migrating here. Okay, so we're going to create the list of tables, and we're going to order them by dependency. And the reason why we're doing that is so that the tables that do not depend on any table are first, and the tables that depend on other tables can be last. For example, if I was to go into SQL once again, if you look at a table like categories, the categories table does not need suppliers, for instance. It doesn't need the products table. It doesn't need the customers table. As you can see, all it has is the category ID field, the category name field, and descriptions. It doesn't contain any fields that belong to any other table. So that's how I know that the categories table does not depend on any other table in this migration. So if you were to compare this to, let's even say the suppliers table. So the suppliers table and the categories table do not share any common columns between them. And if you do the same with the customers table, you'll discover that there are no columns that are shared between them either. Now, if you do this with the products table, if I just do select top 1000, you're going to notice the product table contains, of course, its product ID, which is the primary key, but the category ID field, the supplier ID field. So in other words, it does depend on other tables. So think of it like building a house, right? You're going to need the foundations. So the foundations in this case will be things like the categories table and the suppliers table before you can build the walls, right? So in other words, this is going to be like the products table that references the categories table and the suppliers table, right? So the migration order for this will be categories because it has no dependencies. But let's write this down. So it's going to be categories because it has no dependencies. We can even, let's even add in a migration order. We can say categories because it has no dependencies. Suppliers because it has no dependencies. The customers table, that doesn't have any dependencies. And the products table. Now, this has dependencies, okay? And we need to be clear about that. Depends on categories and suppliers. Now, once again, how do we know that? If we go into the product table, naturally, it has its own primary key. But we also see it's got foreign keys. That's going to be the category ID field, the supplier ID field. So these are columns that are not necessarily natural inside a product table for this context, okay? The category ID field is natural to the categories table. That's its own primary key. And then the supplier ID field, that's its own primary key. Okay, it's not a foreign key. Okay, so that's how we know. So if we try to load the product table first, Postgres might reject any product with a category ID because the categories table wouldn't exist yet. So it wouldn't even know what you're talking about. So in other words, the foreign key constraint would fail. And once again, that's what we call referential integrity. And it just means making sure the relationships between the tables are valid. We're going to create a list. And we're going to call this tables to migrate, right? We'll start with categories. Then we said suppliers and customers, followed by products. Let me confirm if it's product or products. Okay, products, plural. Awesome. And then I'm just going to read that in. If you want to print it too, we can do that. And if you want to display the tables in the order of execution, then we could actually make it a bit more presentable. So if I do that, and I could use a for loop. So for I, then table in enumerate. Tables to migrate. Then we start with the number 1, not 0. And then print f. Then we just add a bit of space or indent. I dot table. Oh, I should wrap that with that. So this is going to be the index. So it's going to be like number 1, number 2, number 3, number 4. And this is going to be the table name. And if I just hit that. So if I don't include number 1 in the second argument of enumerate, it's going to start from 0. So the count will start from 0 and then 1, 2, 3. As you can see right there. So I'm telling enumerate, start the count from 1. I can even tell it start from 100. And it'll do that. But yeah, of course, we want to start from 1. Okay. And we can also add the total number of tables we're counting, right? Number of tables to migrate. And that's going to be the length of the tables to migrate. Now, I'm a big believer in variables. So let me do it like that. Still the same thing, just, and of course, if you want to add a line break, just add the backslash and the n, then hit enter, and it spaces it out. Okay, awesome. Right. The next step will be to start the pre-migration checks. So just for formatting purposes, I'm going to type in print dash dash times 70. You're going to see what it does. You can see all these dashes. If I say print times 5 on the dashes, you can see that. If I say 50, you can see that. So just for formatting, I'm just going to use, I do like the equal sign, I'll be honest with you, so I'm just going to use that. So we're going to start with row counts. So let me just add, I'm going to add this here. Okay. And I'm going to start with an empty dictionary, right? Just read that. And what we're going to do is we want to find the row count for each table. So inside the try block, we're going to first create a for loop, and then we're going to add the SQL query inside the loop. And then we're going to fetch the results and store them inside a variable using fetch1. So I'm going to use the try except blocked again. So inside the try block, we're going to run we're going to create a for loop. Okay, so for table in the tables to migrate list that we created earlier. This is what we want to run. Okay, so I'm going to I'll type in query. I like SQL query. And then we're going to use f strings again. We're going to type in select count star as total rows from the table that we're currently looking at. So it will first do it around the categories table, and then it's going to do it on the suppliers table, and then the customers, and then the products. And then we're going to use the SQL cursor to execute our SQL query. I'm going to call this row count query actually, just to be more specific. And then the count, I'm going to create a variable for count, SQL cursor. I'm going to use the fetch1 operator once again, followed by 0. So open bracket 0, close bracket. So if you do want to see what each of this looks like, you could actually just, I'll show you an example of what these queries actually return. Okay, so I'm going to type in test query. Okay, and I'm going to say select count star as total rows from, we'll say, the categories table. Okay, and then we're going to say SQL cursor execute our test query. So once it executes our test query, this is what we want returned. We want the count. So SQL cursor fetch 1. And then we'll print the results. Okay, as you can see, the result is 8. So we have 8 rows inside the categories table. Now we can confirm this by going to SQL Server and then doing a select top 1000 on it. And as you can see, there are 8 rows in the categories table, which confirms that this is correct. So if you actually want to see what fetch 1 actually returns, I can show you. In fact, let's do print, and I'll show you what it gives us. Actually, I think it's worth doing it like this. Aha, I think that's actually more better. Okay, so you can see it returns this result. So every single time we add square brackets and then add in a 0, we just want to extract the very first character in our results. That's what we're returning here, because we don't care about the entire tuple. We just care about the very first result it gives us. So we can do the same thing for the customers table. If we just change the table to customers and it gives us 900,000 records, we can do the same for suppliers. And of course, we can do the same thing for products. And that's what we're doing inside our for loop. We're telling the for loop to do this exact query, but do it for every single table in SQL Server. So now let me get rid of this. But in our case, we're telling SQL this time to store the results inside our dictionary. So the counts will go inside our dictionary. And don't worry, you're going to see what this looks like in a moment. For now let's complete our table. So table, and then we're going to use colon, and then add 15. And then I'm going to space this, and then I'm going to add in count colon greater than 12. And then I'm going to type in rows. And then finally, we're going to calculate the totals. And then we're going to display the results. Okay, so total rows equals the sum of baseline counts. And we want the values. And we're going to print using f strings once again. I'm going to open up squiggly brackets. And I'm going to use dash and then space it out times by 30 so that we have 30 different dashes on the same line. So we're trying to create like a table output instead of just the results by itself. And then print, let's have f strings again. And then we'll have total colon 15. And this is all formatting. Spaced out. Total rows. Colon greater than 12. And then comma rows. And this is going to be, I'm going to break into a new line as well. And then type in baseline captured. Do you want a exclamation mark? We'll leave it. I think I want it. I think it's, no, let's take this out of the loop. So it's just, yeah, it's just outside the loop. So we complete the loop on each table and we're getting the totals for the tables. So let's run that again. Aha, much better. Can you see the output? So this, so if you see all these dashes, that's what this created. And the totals here was created by this. And we have our baseline captured. Awesome. So this is going to be our source of truth for validation. So we're going to compare the counts we do in Postgres against these later on. If the counts do not match, then we know we've lost data in one of the migration steps. And if anything goes wrong, we'll raise an exception. So let's do just that. Failed to get baseline counts. And you're going to tell us the reason why. This is an F string. And then just raise an error or an exception. So now we've got our baseline row counts. I think it's safe for me to point this out to you. Using queries like this in a production environment is not recommended because malicious users can take control over what tables are being inputted into our queries and add their own tables in, or even change up the query, because malicious users will have control over what queries get inserted into this, especially the fact that we're using F strings, right? So for production purposes, this is not recommended. Now let's move on to our next pre-data quality check. We want to focus on the null customer names, right? So we want to count every single row where the customer name contains a null, because if you remember earlier, we were looking at the customer table and we noticed in the customer name field, there were so many null values inside. So as you can see there, and if I just scroll a bit more, you're going to notice a few more. There we go. So we want to count how many nulls appear in the customer name field in the customers table. So let me just type in print, and then we're going to type in equal sign multiplied by, let's say 50. Yeah, that looks nice. Okay, break into a new line. And let's follow a similar format to what we used for row counts. In fact, let's be lazy. Let's just copy this. Just apply it here. So check to null counts. And it's specifically for customer names. We're going to open up a empty try except block. And then we're going to start with the SQL cursor that we created earlier. Execute. And then let's just write select counts as total, or let's say null count. Keep it simple. From customers, where customer name, in fact, let me just wrap this in that and then just break into a new line. Okay. Where customer name is null. So when it executes that, we want to read the results into this variable, null names. Fetch one. So you added that. It's also worth noting, actually, let me create a quality issues dictionary. And this is going to be an empty dictionary where, in fact, so let's make it a list. I think it would make more sense if it's a list. We're going to create an empty list, and this is where we're going to capture all the data quality issues we identify. Okay, so I'm just going to read that there. And now, so if the total number of null names found is greater than 0, you're going to append this quality issue into our quality issues list, right? So I'm going to say null names, and we want to format this null names customers with null names. Remember, this is the total. We're doing a select counts as null counts. So we're counting how many nulls appear inside the customer name column. And this is what's going to show up here because we're fetching this. Okay, so let me just quickly print quality issues. Okay, so can you see that? So this is what it returns. And I think it's worth us noting that we need 1000 separators. So I'm going to add a colon and then comma after null names. As you can see, it's going to produce the results here. In fact, maybe we should add the check here. Let's see what that looks like. In fact, let's eliminate all this. I'm going to keep it simple. I'll say check 2 null counts null checks on the customer name. Okay, and then we'll do a line break. Also, okay, reason being because we want to do all the checks inside this try block. So that leads us to the next check, which is invalid email formats. I did notice when looking at some of the emails, if I just expand the emails very quickly, I did notice that some of these are a bit odd. What I mean by that is, if I just quickly filter to email, it's like at invalid. Email like invalid, should I say. All these emails appear. Now to me, these look like dummy emails, right? And this may be dummy data used by developers to test features. So this shouldn't even appear in this, right? So it could be junk data that was never cleaned up in an old system. So we need to highlight these. This wasn't actually initially part of our original checks, but as you explore the data, you begin to discover new issues on the go. And this just happens to be one of them. So this is actually a new check that wasn't a part of the plan. But that's no problem for us. We're going to include it and let the data team know there are issues in the email column too. So I'm going to do a count on that. So select count star as total, what should we say, invalid emails? Invalid email counts. Let's say from customers where email like, then we add a wildcard, the percentage sign, and then we say at, and break into a new line. I should also, let me undo all of that for a split second. This should be wrapped with more double quotes, and then I break into a new line. I think it's easier that way. Okay, so we're email like invalid, and that's similar to this query here. Okay, so if, oh actually, let's also create a variable that captures all the invalid emails. So SQL cursor x, or rather fetch all, or fetch one, should I say. And then bracket 0. And if invalid emails is greater than 0, then we want to append this into our data quality issues list. And we want it to be quite similar to the previous one. Invalid emails with, say emails with invalid handles. We can even say invalid email formats. dots there. Okay, so if I was to, let's even clean up the list. So start from scratch. Then we can print the quality issues here. And let's add 1,000 separators to the output here. We add a colon and a comma. And if I was to just rerun this, in fact, I think it's worth us adding that into this block. Okay, awesome. So it's got 1,000 separators now. And we can move on to our next check. So we've done the null checks. We've done the invalid email formats. Let's just put this in caps. The next one we want to do is negative values. And to be more specific, let's start with negative product prices. Right? So we're going to move on to this one. And basically, we just want to highlight any values that are logically impossible. So for example, product prices that are less than 0. So you can buy a product that costs you $50 or $75, but you can't buy a product that costs you minus $50. If the literal price is negative $50, that's not possible because that means they're the ones giving you money. In our use case, this is not possible, okay? So let's just specify that and highlight every single figure that is negative in the prices. Okay, so let's just do our selects. Select counts star as negative counts. Negative product counts. Negative product prices counts, right? Do from. This is going to be from the products table. If I was to go into products, so we're going to be looking at the unit prices column, right? And we can't have any negative values inside here. That would be wrong. So we want to specify that from products, where unit price is less than 0. We can run this check here as well, where unit price is less than 0. Are there any? Of course, we want to do this in Python as well. And there are. Interesting. Would you look at that? There's quite a few. So that's something we need to raise with the data team. Okay. Interesting. So we're going to capture all of this. Okay. So we're going to call this negative price variable. So SQL cursor. We're going to use fetch one. And we're going to capture the very first value in our tuple. So if negative price is greater than 0, I want you to append this to our quality issues list. And then I'm going to note negative prices are negative or contain negative values or negative prices. Okay. And once again, I'm going to comment out that one and print it out here. So I'm going to do comma or colon comma so that we add 1,000 separators to our results. And then we're going to do our next check. And this one's going to be about stock this time. So similar check to the previous one. We just want to confirm that there are no negative stock included in our results. So once again, this is something we can actually check inside our products table. So I'm going to replace this with stock quantity this time. Let's have a look. So do we have any values that are negative in the stock quantity column? Let's find out. And we do. So this is not good for the data team, that is. So they really do need to look into this. What could be the reason for these issues? We'll highlight the fact that they exist, and we'll just let the team know that there's quite a lot of them. Wow, bear in mind we've only just filtered the top 1,000. So imagine if I just take this off and just run this. There's almost 1,500 records for this. So 1,467 values or rows that contain a negative stock quantity. Interesting. Okay, we'll highlight this nevertheless, and we'll just let the team know that this is something they really do need to look into. So SQL cursor, and to be honest, you can just copy and paste this, but you've got to be really careful. Negative product price counts. So I'm going to say negative stock quantities counts, where the stock quantity is less than 0. Now, negative stock quantities is what we write here, and we replace that with that, and replace that with that. Contain negative values. We can actually say negative. We can say products for this actually. Okay, then we comment this out, run this again. So let's see if this worked. And yes, 1,467 products contain negative values. Let's even say with negative stock. And that, yeah, let's do that. Let's keep that. So 1,467, that matches the number we have here. In case you can't see it, let me just drag this here. So if you see the bottom right of SQL Server, 1,467 records, 1,467 rows that contain negative stock quantity. And we can use that to match what we have in Postgres once we do that reconciliation. Now we need to do another check. This time we're doing a check on the orphaned foreign keys. Now this one's an interesting one. So let's go into SQL Server, and I'm going to open up a new tab. So select star from products, let's just say, and execute that. Okay, so we have 150,000 records here. So what I'm going to do is I'm going to do select count as orphaned records from products where not exists inside this query. Select one from suppliers where, and I need to add an alias for the products table and an alias for the suppliers table. So where the supplier ID in the suppliers table equals the supplier ID in the products table. That's what we want. So let's run that. And we have 24,700 records returned from this. Okay, so basically what we're telling SQL here is we're going to use the where clause to check the list of products and only filter the records that do not exist inside this subquery here. So we're treating this subquery as its own table. its own data set. This is basically just a list of every single supplier that's linked to the suppliers that are mentioned in the products table only. Remember, this is only the list of suppliers that actually exist in our products table. And this is only counting the ones that do not exist inside here. So if we want to go further, we can add the product ID, the product name. I think it's product name. Let's look at the columns. Yep, product name, and the supplier ID. And then let's also, let me just get rid of that. I'm going to add a comma. And then I'm just going to copy this. And then I'm going to create a group by operation. And then I'm going to run this. Interesting. So these are all the products in the product table that contain a supplier ID that does not exist inside the suppliers table. So can we confirm if this is true? Let's even open up. Let me see if I can find. Okay, let's use this. I'm going to drag this here. So I'm just going to pin this one here, and then I'm going to pin this one here. So let's just check real quick. Okay, so where supplier ID equals, and we're going to pull a supplier ID from. We can even pick the first one. We'll pick one from the results of our analysis. Let's confirm. As you can see, this supplier ID does not exist in the suppliers table. Let's try another one. Let's try 5752. Does it exist in the suppliers table? If I run that, the answer is no, because it's returning nothing. Okay. So if I try 1, it returns 1. If I try 5, it returns 5. But if I try one from my results from before, nothing gets returned. So that means this is an orphaned record, and it simply means that we're including suppliers that are not included inside the suppliers table. And once again, there may have been a process that may have ran where this supplier was deleted or removed from this table, but it's not reflected in the child table, which in this case is the products table. So that's possible, or this supplier simply doesn't exist, but we're going to mark this as an orphaned record. Okay, so select count star as orphaned records from products. And in all honesty, we can actually just copy what we have here, but let's not be lazy this time. Where not exists is in select one from suppliers. Where supplier in the suppliers ID inside the suppliers table is also in the one in the products table. Okay, and let's say orphaned foreign keys. Let's actually change that to FKs just to make it simpler. SQL cursor, we're going to use fetch 1, and we want the first value from that results. So if orphaned foreign keys is greater than 0, I need you to append this inside our quality issues list. Let's use indentation through the tab key. What do we call this? So orphaned foreign keys, we can say products with orphaned foreign keys. And then we can print Well, actually, we don't need f strings. We can just say quality issues. And then we comment out the one we used previously. Okay, so let's run this. Let's see if this works. Let's try this again. So select count as for orphaned records from products where not exist. Select one for suppliers. We didn't add an alias for this. And on top of that, we didn't actually add an exception. So let's even say error. We can do that. Okay, so error, unexpected issue for now. Unexpected issue. So let's confirm if that actually works. This needs to be an f string. Raise, because there was a problem. Yeah, as you can see, this error is telling us that the multi-part identifier for SGP supplier ID cannot be bound. And that's because we didn't actually add an alias for the suppliers table. So I'm going to do that right now so that it's able to understand that I want you to point to the suppliers table for this. Okay, now let's look at the results. Awesome. And this matches the number that we saw inside SQL Server. So if I just drag this here, as you can see, 24,700 records are returned for the orphan foreign keys check. Awesome. Let me just make sure that this is 1,000 separator as well. And we are well on our way. Brilliant. That's good. I love that. The final one we want to do is the future dates check. Okay, so we want to filter to the record where the created date is greater than the get date, right? And I'll show you what I mean. I'm going to open up, let's even do select star from customers. Let's see what that looks like. So if I do where created date is greater than get date. Get date is going to give us the current date and time in SQL Server. So if the created date is greater than the current date, that means the created date is later than our current date and time. And in our case, this should not be possible, right? Because you shouldn't be able to find customers created in the future when we're reporting on data in the past, right? Historical data is captured about events that have happened in the past. So we shouldn't be recording any data that's going to happen because we're not trying to predict data for this scope. It's out of scope. If I was to run this, let's find out how many of these are reporting on dates that are after our current date. And there's quite a lot. So if I just make this a bit smaller, you're going to see the row count is over 9,000 records. So this is not good. Why has that happened? Right now, the answer is not our business. For now, what is in scope is just reporting that there are dates that are beyond our current date, right? So as of the time of this recording, if I show you what that looks like, the current date is January the 4th, 2026, and this is 5:39 p.m. And we are seeing dates that are beyond January the 4th. There's January 25th here. We have January the 9th, January 17th. If I even scroll down, we can even order by created dates. Let's even say descending, okay? We want to see how bad this is. Interesting. So we have dates as far as February. So this is interesting. Why is that happening? Out of scope once again. Our job is just to highlight these issues exist. So what I'm going to do is I'm going to go back into VS Code. And then we're going to do what we've been doing all this time. Select count star from customers where and let's say as future dates count, where created date is greater or later than get date. We want all the future dates to be captured. Now, if future dates is greater than 0, we need to record this inside our quality issues list. Should we say customers with future creation dates later than current dates, let's just say. And we know that there are thousands, so we're going to add 1,000 separators so that the formatting is nice and clean. Let's comment out that one and then leave that one there. Okay, so run our data quality checks. And this matches what we have in SQL Server. As you can see, the same query returned 9,076 records. Awesome. Okay, so that's our pre-data quality checks completed. So now what we need to do is we need to now just format this a little better. Okay, so I'm going to comment this out. If quality issues are true, meaning that if there is any data inside the quality issues list, this is what I want you to return. Data quality issues found. And we're going to migrate as is, let's just say. And then we're going to say for issue in quality issues, print the issue. Okay, so this is going to split them into separate lines, because before, if I just comment out, well, actually, you can see right there, all of this is on the same line and it doesn't really look nice in the outputs. So let's just format the outputs and just make it a bit nicer to look at. Yeah, that's better. Okay, and also what we need to do is let's also add bullet points, or at least let's add, let's include, should we say, I just want to make it consistent. So I'm going to press the tab button once, add an arrow, and I'm going to copy this and apply it to all the other outputs. Okay, just for consistency's sake. Let's also add an else for this. Else, if there are no data quality issues, print no data quality issues identified. Okay, so let's run this again. Okay, that looks better. And maybe I should add a line break for that. So I'm just going to add backslash and n. And then let's run our data quality checks again. Good. Nice. And that's our pre-data quality checks completed. The next step is going to be getting the table schemas. So we're going to do this by querying the information schema, okay? So the information schema is a view inside SQL that contains all the metadata about every single table in every database. So I can know things about every column name in a table and their data types, their ordinal positions, so whether they're first or second or last in the order of columns, or whether it's nullable or not. So it's a great tool for auditing each database in SQL. And I'm going to show you what it looks like actually. So if I just get rid of all this and say select star from information schema, if I say columns, I get to see, and also if I just filter by table name, I get to see every single column inside, let's say, the customers table, as you can see right there. And if you don't believe your eyes, you can also see the customers table on the side here and just compare notes. I'm going to click on column and expand that. As you can see, we have 1, 2, 3, 4, 5, 6, 7. 7 columns, and as you can see here, we have 7 columns listed. So this is the information schema for you. As you can see the schema it's from, the table name, the column names, the ordinal positions, so how it's ordered inside SQL. So this is all the metadata associated with the customers table, as long as it pertains to the columns, right? So this is what the information schema offers us, and it's super useful when you're auditing your tables or your databases. Now, we're going to go back to VS Code, and what we're going to do is, so we need to create an empty dictionary and another try except block. Okay, so I'm going to type in table schema. I'm going to type in try pass except exception as E, and that's going to be pass 2. And in the try block, what we're going to do is we're going to write the query to get the information about each table's column, similar to what we did here. But of course, we're going to do on a table by table basis. So I'm going to type in for table in tables to migrate. If you remember, this is the list that contains all the tables we're migrating. The schema query is going to equal, let me just break into a new line. Select, and we want to be specific. So what we want is, we want the column name. What else do we want? Let me just look at this. What columns are useful to us in the information schema? Yes, column name, that's what we want. We also want the data type. So where can we see that? Ah, data type right there. Data type. And we also want the character maximum length, right? So if I just break all of this into new lines, if I say where table name equals that. So in our case, let me even filter to these columns. So that's what we want, okay? And also, let me just very quickly, let me just go back to that. I could just comment these out, to be honest. And then select star. We want to see if this is nullable or not. Aha. So is it nullable? That's what we want to. Is nullable. Okay, awesome. This is what we want. Okay, let me just format all of that. And then I need to also order by the ordinal position. Okay, now we need to load this into a data frame. So I'm going to type in schema data frame pd read SQL, and the first argument is going to be for my schema query, and the second one is going to be for the SQL connection. Now, let's just print the schema data frame and let's see what this returns. So as you can see, it actually returns what we expect it to, which is good, good, okay, and we can ignore all those user warnings. Now the next step would be, let me just comment this out, and then we type in table schema, and then we add table, and then we're going to add in the schema data frame. So this data frame will be passed in to our dictionary, and we can use the f string to, let's break into a new line as well, to print the tables that are included. So let's move on to the next step. Now we're going to map the SQL Server data types to the Postgres data types, because SQL Server and Postgres speak different languages when it comes to data types. For example, SQL Server calls a true false column bit, and Postgres calls the same column a boolean, right? So they're the same thing, but they just have different names. So we just need to make a translation dictionary. So we're going to call this type mapping. We're going to create an empty dictionary. So int in SQL Server would be integer in Postgres. Big int in SQL would be big int in Postgres. Small int in SQL Server would be small int in Postgres. Tiny int would also be small int. Okay, so I'm just going to speed this up, and then once we're done, we can resume to the next step. Okay, so we've completed all the mappings, and I'm going to hit enter, and I'm just going to go into the next cell. So let me just say SQL Server to Postgres type mapping, say PostgreSQL, then so for SQL type, comma, PG type in the list of type mappings, and because they're dictionaries, I want the items. I want to print the SQL type, and this is a formatting thing. And PG type, let's see what that looks like. Items, let's change that to items. Let's even add arrow in the middle of them. Yeah, so if you see what the 15 is doing, by the way, all the arrows will be quite close to the SQL Server types. So by adding 15, I'm spacing them out. You can add 1 if you want. You can add 100, which will go all the way to the right. But maybe 13. 13, okay, let's say 17. That's a relatively good balance. We've been dealing with SQL Server a lot. The time is now right for us to start looking into Postgres. So for step 8, we now need to create the tables in PostgreSQL. And if you look at pgadmin, we have our database, but this database doesn't have any tables in it, right? So we need to create the empty tables inside Postgres so that we can actually load data into them. And we're going to use the schema that we got from SQL Server and then convert them to Postgres create table statements. The first thing we're going to do is add our for loop. So for table, in tables to migrate, we need to get the schema from the table schema dictionary that we created, and we're going to pass in the table that we're looking into inside the for loop. And then the PG table will equal the table, but it's going to be in lower cases. Now we also need to drop the tables if they do exist, right? If we find out the tables exist, let's drop the tables, okay? So let's just use PG cursor, executes. So drop table, if it exists, then we'll pass in PG table. And we're going to use cascade. So what on earth does cascade do? So if a table has a foreign key pointing to it, cascade removes those two. So without cascade, this drop statement is not going to work. So let's now build the create table statement. So for, let's say IDX for index, and we'll say row. Inside the schema, and we're going to use iterows. We want the column name, and we're going to use the column name inside this row. So I know some of this is a bit complex, so try not to lose me here. And then we're going to say SQL type. That's going to be row data type. So pull in the data type as well. So it's going to be the column name, and then it's going to be the data type right next to it. And then the base type is going to be from the SQL type, and we want that in lowercase as well. PG type, that's going to come directly from the type mapping. And we're going to use get base type. That's going to be the first argument, and then we're going to use text as the default. So with this get method, the first argument is the base type we want. So the data type we actually want for this column. And the second argument is basically what we want the default to be if the base type doesn't work. So it's basically our plan B or fallback option. Okay, so we're basically telling Python, if the type exists in our mapping dictionary, use it. If the type does not exist, then just default to text instead. And text is just another name for string, varchar, etc. Now we need to handle the primary keys specially. So we need to add 3 conditions that have to be true in our if statement. Okay, so if the index, so remember the index here, if the index is equal to 0 and the column name ends with ID and integer is in the SQL type, and then we'll save in lower, then we'll add, that reminds me, we actually do need to create a list for this. So let me just add it here. So that's what we're going to use for this part. Append the column name. I'm going to use serial primary key. Otherwise, append column name and just use the PG type. So if you meet all these conditions, we consider you to be a primary key, and therefore we're going to create the primary key in a special way. So we're going to use the column name and this data type for the primary key. If you're not a primary key, then just get processed like everybody else, the column name and then the data type we've identified. So why are we doing this? Why are we using index equals 0? Why do we want it to equal 0? Because remember, in Python, the first column is usually 0, and the first column in a table is usually the primary key. Okay, usually, I say usually, right? You know, you get some funny cases where it's something else, but in this situation, we want the primary key to be 0. I mean, if you go into SQL, if you go into a lot of the tables we've been looking at, you notice the primary key is the first column in the table, right? If you look at customers table, custom ID is the first one. We just looked at suppliers and categories, etc. Right? Also, it has to end with ID. So if we look at, let's say we look at the information schema here. Select star from information schema for columns where the table name is equal to products. So let's just run this. In fact, I can even do it here. And column name is like ID, and data type is equal to integer. If I just run this, you're going to see something interesting. Let me even filter the table name, column name, data type. We can even add ordinal position, right? If I just run all this, if you look at product ID, category ID, and supplier ID columns, this fulfills conditions 2 and conditions 3 because each of them have ID at the end of their names, the header names, and each of these are also integers. However, only one of them is positioned first in this table, and this is what this condition's about, right? So if you want to go a step further, you can even do condition 1 equals this, condition 2 equals this, and condition 3 equals this. Okay, if you want to do it like this, right? I'm not saying it's compulsory. It's just for the sake of readability, just to identify all of the conditions we have here. Okay, so condition 1, this must be first column in the table. Must be first column in the table. Condition 2, ends must end with ID. And condition 3 must be integer, data type. If it meets all 3 conditions, we're considering this to be a primary key. And in this case, the product ID is the primary key of this table. It's very important that we identify this, okay? Now let's continue to create the table. So we're going to get out of the for loop, and then we're going to do column string. I'm going to do comma. Let's even break into a new line. And then maybe do this. Don't worry, it's going to make sense in a second. We're going to add column definitions. And then we're going to say create query. It's going to be an F string here. Now, create table. We should actually say PG table. We need to be very specific. We're going to add column string. So this right here. We're joining all the column definitions together, and this is what's going to form this. So you're going to have things like the column name, the data type, and any constraints that we've specified for it. So I'm really hoping this works. So PG cursor, execute create query. So we're going to run that, and then PG connection. We're going to use commit, okay? This is actually what's going to make the query happen, okay? It's one thing for us to execute the query, but this is actually what's going to submit our request to PostgreSQL. And if all that works, then we should, let's print something. We're gonna have to break into a new line. And let's just, no, let's not, let's do like this. Okay, 40 maybe, or should we say 55? Let's say 55. This is just formatting stuff so that the output is clear. I'm going to say all tables created successfully. So we'll add a success message. Let's just say, and for now, let's just say print unexpected issue. Interesting. Okay. Column name. Let's have a look into this. I think it should actually be in caps, I believe. Data type 2. The reason why I say I believe it should be in caps because in SQL Server, that's how it's presented. If you look at these ones, can you see that it's all in caps? So I think it's case sensitive. Awesome. Okay. All tables created successfully. So let's look at Postgres to confirm if this is true. So this is our transaction UAT database. Okay. So if I was to refresh the transaction UAT database and then go to schemas and then go to tables, as you can see, we have 4 new tables. So we have the categories, customers, products, and suppliers tables, all in lowercase. So I'm going to right click and then go to view, edit data, first 100 rows. I'm not expecting any data to be inside per se, but we can now see the tables themselves exist, right? So if I change this to interesting, as you can see, the categories table actually has customer ID, customer name, email, and phone. But if I go to SQL, if I go to categories, we only have 3 columns here. So clearly something's not right in one of our steps. So if I was to go back into VS Code, I need to figure out where it went wrong. Let's see if it's somewhere around here. Would you look at that? We've hard-coded the customer table name into our query, and that's what's causing the problems. So we need to change that. We need to add table. We should not hard code. This is why I don't like copying and pasting code from one environment into another. I like writing things from scratch. That's just me, right? Now, let's rerun all those steps again. So I'm gonna do execute cell and below. Okay, it's looking a bit more normal. I need to just make sure that, okay, let me just make sure we're line breaking in the right place. Okay, we'll still add the line break here. I think what would be better is if I just add maybe on top of here. Okay, that looks better. And if I just add print, then just times that by, let's say 10. Remove that line break. Okay. We can add a line break around. I'll do this. This is the cheat code for line breaks. Awesome. Okay. Okay, maybe not like that. Okay, I'll take that. Awesome. Okay, but we've now corrected the issues with the column names. The right columns should now be in Postgres. So if I was to re-execute this, okay, let me see what the issue is. I'm gonna re-execute all the steps. We'll see if we bump into any issues along the way. Saying all tables have been created. It's because the customer ID is no longer in this table. So it should be category ID, I believe. Awesome. Okay, that's good. If I go to products, view edit data, first 100 rows. Okay, this specific object is not found. Let me have a look myself. Select star from public customers. Don't need to do all that. right? Okay, we have that. If I say products, okay, that's good. Suppliers, awesome. Okay, so we have our tables inside Postgres now. So let's sharpen the except block. And I'm going to use the error handling provided by psychopg2. So I'm going to use error. And what I'm going to do is, in fact, I probably can leave the original one there. But I'll just create a new one. Okay, and this time I'm going to type Postgres experienced an error while creating a table, let's just say. And if that happens, we want you to use your connection to roll back any changes, okay? So we're going to be utilizing rollbacks, right? And of course, just raise an error while you're at it. Okay, so what does rollback actually do? So if something goes wrong, rollback will just undo any changes and it's going to keep the database clean. And this aligns with a concept in database management known as atomicity. And this is where all database operations succeed at the same time or none happen at all. So in this case, we want to create all tables successfully or none at all. And using rollback helps us do this. We're basically telling Postgres if anything goes wrong, go back to the original states you were in before we ran this operation. Okay, so if I was to run that, it should have no issues. Awesome. Okay, nice. So now we're going to move on to testing the migration with the customers table. So before we migrate all tables, let's just test our approach with just one table first. In fact, it's probably recommended we try out a table that has the fewest amount of rows inside it. Now, the test table, we're going to use, we're going to say the categories table. Reason being is because it's only got 8 records inside it. So we want to test a small amount of data first. And if we're comfortable with testing more, then we'll do just that. Okay, so I'm going to say PG table. And this is going to be the test table, but in lower cases. Okay, so let's set up the error handling. As E. So we're going to print 1. We're going to read from SQL Server. I'm going to say extract query. Let's just call it that. Select star from PG table. Test data frame. And then we're going to say PD read SQL. I'm going to use our extract query. We're actually going to pass in the SQL connection so that it's able to connect to SQL and pull the data from SQL Server. And if this works, you should be able to print the number of columns, or rather the number of rows in this data frame. And that's just the first step. The second step will be converting the data types, right? So let's say step 2, transforming data types. So I think it may be worth us using the customers table actually. Let's use the customers table, right? So consider this more of, edge case testing, because I think the customers table is one of the largest tables we've got. So let's just go for it. If it works for the largest table, then it should work for the smaller tables. And let me just check the customers table for a moment. Okay. Is active. So is active is a Boolean. and in SQL Server it's known as bits. Okay, let's play around with that. So if is active is inside the data frame columns. I think it's test data frame actually, isn't it? Then we want to convert this column. So that's all we're doing. As say type Boolean. So we're saying if you find this column inside the list of columns in the data frame, then convert this column into a Boolean. And we can say if it's success, converted is active into Boolean. Or we can say from bits to Boolean. Yeah, cool. Then the final step would be to load this data into Postgres. First, we need to prepare the data for loading. So let's say that. And we're going to create data tuples. We're going to use list comprehension this time. So tuple row for row in data frame to numpy. Should be test data frame really. Okay. So what we're doing is we're actually trying to convert the data frame into a list of tuples, and we're preparing it for a bulk insert. This is why we're using the list comprehension here. But essentially what we're trying to do is, because we want to load this into Postgres, we do have a few options, right? We can insert every single row inside our table into Postgres one by one, or we can load them in batches. Okay, so if we load it one by one, that can take a long time because we have over 900,000 records. It's probably best for us to just bulk insert it. Okay, and what that simply means, it just means that we're inserting the data in large buckets at a time. So one bucket can have 100,000 records, and that simply means that we load all the records in 9 buckets, right? So before we do that, our data is currently inside a pandas data frame, okay, the test data frame here. So we need to convert it into a list of tuples, right? Which is what we're trying to do here. And that's going to help us load it in bulks, okay? So each tuple is one row from our data frame. So let's continue. So I'm going to list the columns, and I'm going to do another list comprehension. Okay, so I'm going to do column lower, and this is going to be for the column in the test data frame columns. So we're looping through all the columns over here, and then the columns, the string. I'm going to do comma. In fact, let me do indentation. I think it's better. I'm going to use the join. I'm going to say columns. So we're joining all the columns together. In fact, maybe thinking about it, that's going to be too big. So yeah, so we're going to have one column, comma, and then space with another column, comma, space. That's how we're going about doing that. And then we're going to have placeholders, okay? So comma, space, and then we're going to use join again. And we're going to use the percentage sign and S. In fact, let me cut this and then add it inside squared brackets. We're going to multiply this by how many columns exist, okay? So it's going to make sense because what we're doing right now is we're trying to create the insert query, and we're trying to include the column names. Now there are different ways to do it. We can literally we can do our insert query, add all our logic, and then the values, and that's going to require us adding S, 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 and that's too long. That's boring. That takes a long time. So the shortcut is just really creating the Python code to make this work, and this is what I'm doing right here. Okay, it's gonna make sense in a moment. Okay, so let me write the insert query. And then we're going to do insert into PG. Oh, let's add the F string table. Then column string. Oh, okay, let me do that. It should be parentheses and then squiggly lines and then column strings. Okay, cool. And then we'll add the values, and then we'll add a placeholder. And then we can now say prepared, let's say prepared, how many rows? Length of data tuples, we'll say rows. Okay, so let's even add a colon and a comma. Let's add it on the outside. Awesome. So this is going to be a placeholder that our execute values function is going to fill in. Okay, so we'll add our fourth step. Number 4 is insert data into PostgreSQL. Now, in the beginning, I told you that I inserted the execute values function into this entire project. Well, this is the reason why. In the first argument for this, I'm going to enter PG cursor. The execute values is going to help us load the data into Postgres. It's going to help us with the bulk insert, right? Now, the first argument is PG cursor. The second one is going to be the insert query. The third one is going to be the data tuple, so the data we actually want to load. And we're going to add page size, okay? And we're going to say 1000. Now we're going to say PG connection, and we're going to use commit. If all this works, then we can say loaded. Let's be specific. Let's make this an F string. Length of data tuples rows. Okay. So now once again, instead of inserting rows one at a time, we're using execute values to help us insert rows in batches. So page size has helped us to batch in thousands. So it's going to insert in batches of 1,000 rows. This is going to be much faster than doing it one by one. In fact, let's add in a final step, okay? Because we want to verify if this works properly. So 5, let's say verify. Oh, we can say verifying. Yeah, let's make it verifying. And we're going to include, in fact, let's do execute, select count star as total rows from the PG table we're dealing with. Okay, always need to make it F string, and then we're going to call this PG count. PG cursor, we're going to use fetch 1. I want the first character from it. We're also going to do a SQL counts, and remember we're going to pull from the baseline counts. Then we're going to say test table. So if the PG counts, so the counts in Postgres, are equal to the counts in SQL Server, this is what I want you to do. I want you to display a success message. We'll say the verification passed. And let's make this an F string. PG counts, of course, equals SQL counts. Now, if it doesn't, you're going to return you're going to say failed, because that's what you've done. You failed. Count mismatch. Let's say pg count does not equal SQL count. Oof, this will be interesting. Let's see if this actually works. But yeah, we'll also say if this migration even worked or not. So the migration test successfully completed. And if it doesn't work, then PG connection is going to roll back anything we've done. Okay, let's give it a go. Verification passed. Awesome. So we have 8 records in. Oh, we said we were going to use. Oh, we used the test table. That should be correct. Okay, let me try again from the top. Okay, so it's now running. Okay, it's inserting data into Postgres right now. Let's see if this works. Awesome. I think it's done. And it succeeded. So our verification has passed. 900,000 records have been processed. So the customer's migration test successfully completed. Awesome. So now the next step is just to include the remaining tables. So we can simply, in fact, let me just add this. So number 10, migrate the remaining tables. So this should be relatively easy. So remaining tables should be, so say T4 Tn tables to migrate if T does not equal customers, because we've already migrated customers, so we don't need that. Okay, so let's create our loop as well. So let's say for table in remaining tables. So the PG table is now going to equal table, and we want that in lowercase. We can even say migrating PG table. Okay, we can even say table let's even have a look. Let's see what that looks like. Okay, cool. Yep, awesome. Let's continue. So we're going to add a try block, accept exception as E. So similar to the first one, we're going to say reading from SQL Server, and the query, should we say extract query, that's going to equal select star from table. We'll say PG table. No, we should say table, shouldn't we? Because it's pulling from SQL this time. So we want to make sure that the name is on point. And then you can see SQL data frame equals PD read SQL. And then the first argument is going to be the extract query, and then the second argument is going to be our SQL connection. And then if that worked, let's even say if that worked, then read SQL data frame f string rows, 1000 separators where they apply. Now let's go to our next step. So what we're going to do now is we're going to prepare the data. So similar to our previous step, so data tuples, so tuple row. So that row is going to be a tuple for row in SQL data frame to NumPy. The columns are going to be converted to lowercase. And the columns string is going to be built by a comma, space, and that's going to be joined using the columns. So the columns are going to be connected to each other. And then we build our insert query. Insert into the dimensional table. Then we're going to mention the columns string that we're building, the columns string. The values will be the placeholders. So let's print, we'll say prepared, the data tuples, rows. Oh, also let's add line breaks again. And then the final step will be to process the bulk load. Say processing bulk load. Okay, and we're going to use the execute values operation. First argument will be PG cursor, second will be our insert query, and the third will be the data tuples, and the fourth will be the page size. And we want to process 1000 rows per operation. So PG connect, commit, and I'm going to say print, and this is going to be a success message. Loaded the length of data tuples rows. But once again, we do want to verify this. Add line breaks. Verifying. And now for the sake of time, I'm just going to copy what was done before and paste it right underneath here. Okay, let me just align them. Okay, PG table's being used. We're not using test table, we're using the normal table inside our loop, this one. And it's not a migration test. And we can also migrate this. Okay, it's aligned with try, so that's good. We could add print fail to migrate. Then let's name the table and then add the reason. Right, let's run this. Interesting. Okay, what we can do is let's restart from a reasonable point. So I'm going to scroll all the way up. I'm going to restart from here. So from create tables in Postgres, and I'm just going to process all these rows, because what's going to happen is it's going to drop the tables and then recreate the tables so that there are no duplicates in our data. For testing the migration, it should be reading this table, right? It should be processing this. But test table is customers, PG table. That's technically what's being processed here, isn't it? Suppliers migration was successful. Okay, let's look at Postgres. Let's look at what worked and what didn't work. Okay, so I'm gonna type in select count star from public suppliers. 5,000. Is that what we expect inside? I'm just gonna scroll all the way to the top. We had our baseline numbers. Okay, so this is what we expect for each of our tables. This is SQL Server. And yeah, let me start with categories actually. There's 8 here. Okay, so that's good. So move on to suppliers. How many rows here? 5,000 here. There's 5,000 in SQL Server 2, so that's good. So next is customers. There's 900,000 records in customers, 900,000 records in SQL Server. Awesome. Let's try products. So 150,000 records here and 150,000 records in SQL Server. Okay, that looks good. I'm just going to, just for sanity, I'm just going to do select categories. I'm going to do my union all again as total rows, and then count, rather that should be table name, and then this should be total rows. Okay, so let me just, I'll say PG table name for that. Okay, from public, then categories, and then we're going to use union all. Select suppliers. Do suppliers this time. Count star from public suppliers. And then I'm sure you know how this works by now. I'm just going to copy and paste these two. Okay, customers, the next one. Customers, and then products, then products. Okay, so let's execute that. Okay, so side by side, let's have these side by side. Okay, categories in Postgres has 8, SQL Server has 8, suppliers has 5,000, this has 5,000. Okay, from the looks of things, this looks okay. What I'm also going to do is just create the with Postgres total CTE as, I can probably come up with a better name later on. Select sum of total rows as grand total from PG, what did we name it? Total. PG totals CTE. And then we can compare that with what we have here. And as you can see, those numbers look correct. Awesome. Okay, so the migration clearly worked. So for row counts, in Postgres, we can confirm it matches. Matches SQL Server. Success. And we can actually turn this to Markdown. Number 2, the data type checks. So let's call them data type checks. And let's call them row count checks as well. So we need to go to information schema in Postgres and confirm the data types match across both platforms. So it is quite an intensive exercise. I do appreciate that. But this is what a data migration project entails. So I'm just going to open up a new canvas. And then I'm just going to select star from information schema, where table name equals, let's start with customers. And let's see what this gives us. Okay. Now, we can actually filter this by column name, data type, is nullable. I'm giving include ordinal position. Okay, if I just run this. Okay, let's see what we get. So once again, you can do a side-by-side comparison with Postgres and SQL. Should have the information schema somewhere. Awesome. Okay, so customers against customers. Data type, as you can see, customer ID is integer on both. Character variant is Postgres' way of saying envarchar, so that looks similar. And then we have timestamp without time zone. So date time, yeah, that's similar. And in Postgres, is active is considered Boolean, and the same is considered bit in SQL Server. That looks good. So the next one we can try out is categories from the top of my head. Let's try that. And then run it here too. So column name, category ID, it looks like it matches what we have here. In fact, maybe it'll help if I just comment this out. I could actually replace it with ordinal position. That may be more useful. Okay, so category ID is integer for both. Character variant is for category name and description, which matches what we have inside SQL Server. So that works. Okay, that's awesome. So let's try products this time. I'm going to try products on this side. Okay, and also look at the nullable columns as well, just to confirm if each of the columns are nullable or not. So can this column contain a null or not? Is it allowed to have empty values or not? So for the primary key, the answer is no. And as you can see, it's the same on both. And for the other columns, the answer is yes. So this is good. And if you want to compare the ordinal positions, you can do that. And then the final table is suppliers table. So let's try the suppliers table. Okay. And from the looks of it, they also match. So this is good. So we can confirm this is a success across both platforms. Awesome. So the next thing we need to check is if the primary keys are duplicated across any of the tables. Okay, so I'm going to try Postgres first. Just going to open up a new canvas. So I'm going to start with, let me just get the categories table. And what I'm going to do is I'm going to write category ID because that's the primary key for that. And then I'm going to do count start as duplicate counts. Now I'm going to do a group by. It's going to be category ID. And then I'm going to use the having operator. Just zoom in a bit. Having counts is greater than 1. So what this is doing is it's grouping by category ID, okay, and it's only going to return the duplicates. So any of the values that are greater than 1, in other words, is a duplicate. So that's what it's going to return, okay? So if it's an empty result, that means there are no duplicates in this table, okay? And that's good. So that means there are no duplicates in this table. So let me actually take this off. You know, you can actually run this without the schema. I just like doing that because I'm a creature of habit. But let me go into SQL Server and open up a new Canva or canvas, and then I can run a similar query. And as you can see, we have no results in SQL Server either, which means there are no duplicates across both tables, right? So let's do, what other tables do we have? We have customers table. The customer ID is going to be the primary key for that. So let's try that. And then we're going to change that to customers table. So let's run that. And once again, no duplicates in the primary keys for that. If we run this same query in SQL Server, there are no duplicates in the customer or the customers table, which is awesome. Okay, now what's next on our list? We have products, so the product ID field. We're going to group by product ID. We're going to query the products table. Let's run this. Okay, that's good news. And then let's do the same for here. Nothing returned. And we're going to do suppliers. Right, let's see if we have any here. Okay, none in Postgres. And none inside SQL Server. Awesome. Okay, so that tells us we do not have any duplicate primary keys, which is awesome. Which means every single primary key in every table across both environments are unique, which is good. The final check is the referential integrity one. So this is how well the tables talk to each other. This is the final one that we need to include. For Postgres, really, we want to figure out if the products table is able to talk to the suppliers table and the categories table, because the product table, if you remember, this is the table that actually contains IDs from other tables. So category ID and supplier ID, right? So we want to make sure that it's able to reference those tables without any issues. So one way of doing that is by doing select star as broken references, let's say, from products, say prod, really should give it a better alias, but for now, let's just get away with that, where not exists is inside select one from suppliers where supplier ID in the suppliers table is equal to the supplier ID in the prod. Okay, right. I'm just gonna do this just to make it distinct. I'm trying to distinguish the different clauses, commands, and operators we use from the tables. Okay, so we have 24,700 here. That's, from the looks of it, it's quite similar to what we had before. So let me just run this. And as you can see, it's the same in both environments. So that's good. From a data quality perspective, it's bad. But from a data migration perspective, this is good. It means our data matches in both environments, which is awesome. Now, let's get to the fun part. Let's actually visualize our data, right? We want to create a bar chart to compare the row counts in SQL Server and Postgres. Now, we already know the data matches in both environments, but stakeholders are not going to be interested in just numbers. So let's capture this in a format that's visually appealing and it communicates the insights much more clearer and in a polished manner, okay? So let's go back to our notebook. We're going to add in another markdown. Okay, I think what we can do as well is we can actually capture all the changes we've made up to this point. So let's load this into our remote branch. So if you see, if I do git status, you can see that we've made all these changes, but we haven't actually pushed it into our remote branch. So let's do that. So git add dot, and then git status again. So it's managed to stage it. So now we're going to do git commit -m, and we can say completed migration notebook, let's just say. Okay, and then say git push origin main. Okay, so now it's captured all the changes we've made. And if we just refresh this, we now have our notebook included. So this is good. As you can see, everything we've done is now captured and inserted into GitHub. Well, let's go back into our session. So we want to create a bar chart, right? So I'm going to start by importing matplotlib, right? And I'm going to do .pyplot as plt. Okay, I think this is a markdown cell, so let's use a normal. Yeah, there we go. Okay, so we need to import. We need to pip install matplotlib. That's what we need to do. So let me open up my Anaconda terminal. I'm going to do pip install matplotlib. And that's going to install matplotlib into our virtual environment, which allows us to create visuals with Python. So once you pip install matplotlib, you should be able to now use the library. So I'm going to type in the % and then matplotlib, and I'm going to type in inline, and this is what we call magic commands. So magic commands can be used with IPython. I'm going to use magic commands with IPython here so that the results are displayed inside the notebook instead of a separate window that pops up. I'm going to type in plt rc params. I think it's actually square brackets. And I'm going to type in figure, and I'm looking for face color. That's the one. Yep. And it's going to equal white. This is what I want. Awesome. Okay. So we're in the game. I'm going to open up a a new code cell. We're going to create a simple bar chart using subplots from PLT. So subplots create two objects, right? It's going to create a fig, and that's going to be the entire image file, and it's going to create ax, okay? And that's going to be the specific area our chart is displayed on, okay? So I'll show you what that looks like. So do fig, then ax, then PLT subplots, and then we'll say fig size. It's going to equal, let's say 12.6. Okay, so this is what I'm talking about. So instead of opening up a new window, I want it inside the notebook. And we're going to use the names of our table from the tables to migrate. If you remember the tables to migrate list, so this is what we're going to use as the table names. Okay, we're also going to need SQL counts. And remember, this is from, if I just open up a new cell, baseline, yeah, let's do that, baseline counts. If you remember this is our dictionary with all the SQL counts, okay? So this is what I want. Baseline counts, we'll say T for table, for T in tables to migrate. Okay, so SQL counts, let's see what that looks like. Okay, good. Okay, and now we're going to get to the Postgres counts too. So for this one, this is going to be interesting. We're going to do pg counts, empty list. And we're going to say for table in tables to migrate. We're going to do pg cursor executes. And we're going to do select counts star from. Always remember to add the F in once I bring in the squiggly brackets. So table, and then we're going to say lower. And then whatever the results are, we want you to append to our pg counts. Rather, actually, I'm already appending, so I don't need to do all that. I need to do pg cursor, and we're going to use fetch one. So let me just run all that. In fact, let's see if this works. Okay, good. So let's create a list of numbers, okay? So these numbers are going to act as the base slot for each table on the x-axis. And let's also set the width of each individual bar that's going to be displayed on the x-axis too. So I'm just going to do x equals, let's say range, and we'll make it the length of the table names, okay? The table names. So remember our table names? Oops, so I just skipped it. That's going to be the tables to migrate. And the width would be, let's say 0.2, actually let's say 0.35. I think that'll be reasonable. So we're going to create a bar for each of the tables. If we want to draw a bar chart, we're going to use the bar method, right? So we're going to use bar from AX, right? We're going to name our bar 1. The first argument is going to be for the bar's position, right? So for each table, we want to render 2 bars. One to represent SQL Server's row counts and the other to represent Postgres row counts, okay? And we're going to use a list comprehension in a clever way to make this work. So it's going to sound confusing, I understand, but try and stick with me here, okay? So for the first bar, we're going to take the center point of the table slot, okay? So let me actually write it, okay? You're gonna understand as I write it. So I'm gonna do square brackets I minus the width. So if you remember the width we've just defined, that's gonna be divided by 2 for I in X, right? If you remember X over there, comma, and we're going to do SQL counts, and then width, it's going to be the third argument, And then the fourth argument is going to be label. Okay, I'm going to write SQL Server. Let me even break into separate lines so that you can see how all of this works together. The fifth is for the color we want. Now, here's where things get interesting. Let me just do FFFFF, then another one. Aha, good. I was waiting for that to pop up. Okay, so I want, I think I want something more, let's go for this for now. And then alpha, or the final argument. So this is just how transparent we want the bar to be, so that they're not too harsh on our eyes. And I'm going to do, I think it should be a number actually, 0.8 for now. Okay, so remember for the first argument, by the way, let me break this down a bit. So the first argument, remember it's going to be the bar's position. So how this works is it's going to take the center point of the table slot, and that's what we have as I, the center point of the table slot. And then it's going to subtract it by half the bar's width. Okay, width divided by 2. So that's going to be half the bar. So this is going to shift it slightly to the left, right? This is going to make sense once we visualize this. Okay, so bar 2, I'm just going to copy and paste. It's going to be very minimal differences. Okay, so for the first one, instead of minus, we're changing that to a plus. Instead of SQL counts, we're using PG counts this time. And for the label, instead of that, we're using Postgres. The color, I think we should use, yeah, let's go something like this. Let's try that. Okay. So I've changed this to a plus so that it's slightly to the right instead of the left. Okay, so let me just hit enter. And then let's create a new cell. Now we want to update the x-axis, and we're going to use the set x label method for this, right? So if I just do ax dot, then set x label, and then I want table as the label. The font weight is going to be, we'll say bold, just to visually distinguish it. Then the font size, we'll go with 12. We can always adjust it. And we also want to give the visual a title. So we're going to use ax.setTitle, and I'm going to call this migration validation SQL Server to Postgres. And then we can just copy these ones. We can copy what we have here. So font weight, bold, font size. We'll make the font size 14, right? Because it's a title. Okay. In fact, let's actually I think it will make more sense for us to place all of this underneath this. Okay. Yeah, let's insert all of this into one cell. Okay, so we'll get rid of that. In fact, before I do that, maybe I should no, let's continue. Okay, I'm just gonna paste that there. And then so that we can see the changes in real time. It'll be easier to appreciate the things we're doing if we can actually see it. Okay. And let me just pull that here. Okay. So we can actually get rid of all this. Okay, so let's run that again. Aha, much better. Okay, so now you can actually see the changes that are being made. You can see the bar for SQL Server is red, and the one for Postgres is slightly green. But I do have a preference for this. Okay, slightly better. And we need to replace all these generic numbers on the x-axis with our table names. Okay, and to do that, we're going to use the set x ticks and the set x ticks labels methods. So in the first one, I'm just going to pass x through, and in the other one, I'm going to type in table names. So let's see how that works out. It's starting to come together now. Another thing as well is we want every single pixel on the visual to be effective. Okay, there's something known as data inc ratio, and that's the concept of making sure that every pixel on a visual is working towards sharing an insight. If there is no use of the pixel on the visual, get rid of it. So in other words, get rid of any visual noise, any visual fluff. It needs to be removed. The x-axis is fine, but the y-axis has to be gone. And the way to do that is by using the get y-axis method, and then set visible to false. Okay, so this is going to hide the y-axis, numbers, and the label. And as you can see, it's disappeared. Let me make this full screen a moment. And let's also hide the left borders. Okay, we're going to use spines to do that. So spines, and we're going to say left. Set visible to false. Okay, we also want you gone. And look at that, it's gone. And you know what? We might as well get rid of. Let's get rid of the right one as well. Okay, so I'm gonna set that to right, and that's gone too. We can also get rid of the top one. So let's change that to okay. And as you can see, it's becoming clearer. And we do need to also make sure that the height of each of the bars is scaled to a healthy proportion, so that each of the bars are actually relative to each other. So this actually is a good segue to talk about logarithmic scales. Okay, so let me touch on logarithmic scale quickly. Okay, so in a migration like this, often you're going to have tables with different row counts. Some tables will have thousands, millions of rows or records, and others may have less than 10, like categories. Okay, so remember our categories has about 8 rows, and the customers table has over, think about 900,000 rows, and products about 150,000, right? So if we have a chart that uses a normal linear scale, so for example, the y-axis has values like 0, 10, 20,000, and then 200,000, 300,000. The categories bar will not even show because of how small it is and how small it would appear compared to all the other bars. Okay, it's literally just going to disappear and it's going to be invisible compared to the others. Like you see here, I can't even see the categories bar right now. So with log scale, we can use the power of 10. Okay, so 10 to the power of 1 is 10, 10 to the power of 2 is 100, 10 to the power of 3 is 1,000, 10 to the power of 4 is about 10,000, and so on and so forth, okay? And what that's going to do is it's going to compress the large values and stretch the smaller ones, okay? It's going to compress the large values and then stretch the smaller ones so that we can all see the bars clearly on the same chart. So when I'm gonna type in now actually. So when we pass log into set scale, set y scale, what's going to happen is the category bars or the categories bar with 8 rows is now going to be seen, and the customer bar or the customers bar isn't oversized. Just like this. That's exactly what set y scale does, especially when you pass log in. The categories bar can be seen, or the bars, and the customers bars can be seen as well. It's not like the customers bars are too large so that it's making the categories invisible and vice versa. Let's also add legends. So AX legends or AX legend. We can just run that. And as you can see, you now know that blue refers to SQL Server and the green refers to Postgres. Let's do this. Okay, so for bars in, what did we name them? We named them bar 1 and bar 2. Okay, so bar 1, bar 2. We should actually name them bars because they're bars. It's plural, it's not singular. So bars 1, bars 2. Okay. So what's going to happen now is we're going to start by creating a nested loop. Okay. So remember, we have 4 tables that we're trying to migrate. Okay. So we want to compare the row counts in SQL Server and Postgres for each table. And that's going to mean that we're going to have 8 bars in our chart, which is what we can see right now. So SQL Server will have 4 bars on this chart, and so would Postgres. So the first loop is going to loop through each of the grouped bars, right? So SQL Server's bars on the chart, and then Postgres's grouped bars, okay? And then that's going to be the outer loop, right? So this is going to be the outer loop. And then we're going to create another loop inside this one so that it looks at each bar within each group. Okay, so for instance, the SQL Server bar that represents the customer's table row count. Okay, and then one that represents the supplier's table. Okay, and that's going to be the inner loop, right? So I'm going to show you what that would look like. So we have the outer loop, okay, and then we're going to have the inner loop for bar in bars. Now the computer will look at the first bar in the group, right? And it's going to calculate its height using get height, which is what I'm going to do. So height equals get height. Oh, it's from it's going to be from bar and then get height. And then we're going to format the text that appears above each of the bars. And we're going to use a ternary operator to help calculate the label for us. Okay, so I'm going to show you what that looks like. We'll type label. We're going to use an f string as well. And I'm going to use integer, then the height. If it's greater than 1,000, I probably should wrap this around with parentheses. Okay, that's better. And it's going to be 1,000. Okay, maybe should be there. And only if the height is greater than or equal to 1,000. Okay, so we want to make sure that we're formatting this correctly. If the height is greater than 1,000, if it's not, then let's just display the height as it is. So if it's like 900 or 700, we don't need 1,000 separators, and we don't need the k after displaying the number. So if I just run that, yeah, we need to. So we're going to need to use AX text. So this is going to help us display the text. So if I type in bar get, it's actually get x plus bar get width, and we're going to divide it by 2, of course. And the height will be times 1.11, actually 1.1, I'd say. And then label, and then the HA is going to equal center. Well, I'll explain anyways. Let me just explain. Okay, so get x, if you see get x, bar get x, so this is going to give us the coordinates of the left edge of the bar, right? The get width divided by 2 is going to calculate half of the thickness of the bar, right? So we're adding these two numbers together so that we can get the exact horizontal center of this bar, which is where the text is going to hover, right? The second argument, this is the y coordinate for the text to go. So we're simply getting the height and we're multiplying it by 1.1, so which is basically multiplying it by 110%. So the third argument is going to be the label to be displayed that we've just defined, right? It's going to be this one here. Okay, so you're going to see things like 12k or 40, so numbers like that. And the ones I'm writing now, so these are just keywords that we can use to style our text. Okay, so HA is horizontally aligned and we want it centered. And then I want to add VA, which is vertically aligned. And that's going to be bottom. Font size, let's make that 9. And font weight, that's going to be bold. And then if we get out the loop, We can say plt tight layout, and then we can say plt show. Okay, so let's run that. And there we have it. So this is what we were after. So if I just click save as, so we can call this migration validation chart PNG. Okay. So if I was to click on the visual, and there we have it. The final thing we need to do is to commit everything we've done now. So let's do git add, git status, git commit, and let's say rendered validation stats as a chart. Let's just say git push origin main to push it to the remote branch. And then if we were to go into GitHub, we should be able to see everything here. Let's just refresh this. Okay, if I click on the chart, there we have it, right there. This is what we created in matplotlib. Awesome. And it's inside our GitHub repository. Okay. Well, that's everything. You've successfully migrated data from SQL Server into PostgreSQL, and you've managed to validate your process through a validation report, which was created and rendered inside matplotlib. So that's great. It's a big project, but these are the things that enterprises need help with. So if you're able to do this from start to finish, then you're one step closer to either getting a data job or getting a promotion, or even becoming more competent in assisting members of your team. If you're in a data team, a research team, a finance or quant team, these are the type of things that you may need if you're trying to move from a legacy SQL Server database into a Postgres one, for whatever reason you may have under the sun. If you want to join my data community, click the link in the video description and you should be able to join the waitlist if there are any spaces available. Apart from that, if you want any projects similar to this one, then let me know in the comments. If there's anything you're not clear about, let me know again. But until then, I hope you stay blessed. Peace.